According to the National Electrical Code, specifically Article 250.104F, metal raceways, enclosures, and equipment must be grounded or bonded. Now let's delve into how this requirement applies to metal raceways running from a feeder panel to, for instance, a 12 by 6 inch can use to feed receptacles or lights via metal-clad cable or electrical metallic tubing. The key differentiator lies in whether the raceway involves a straight pull-through of conductors or incorporates taps and splices within the enclosure. If the metal raceway is utilized as a straight pull, meaning conductors pass through the raceway without any interruptions, taps, or splices, then, according to the NEC, it generally does not necessitate additional bonding or grounding. In this configuration, the raceway itself serves as a continuous grounding path, effectively carrying any fault current back to the feeder panel. The inherent continuity of the metallic raceway provides a low impedance path for fault current, fulfilling the grounding requirement. However, the situation changes significantly when taps or splices are introduced within the raceway system. Should the raceway system include any points where conductors are tapped or spliced, the code mandates that the raceway must be bonded or grounded. The rationale behind this requirement is that taps and splices can introduce potential discontinuities or points of increased impedance within the grounding path. These discontinuities may compromise the raceway's ability to effectively conduct fault current, thereby elevating the risk of electrical shock or equipment damage. Bonding or grounding ensures that the raceway remains at ground potential throughout its entire length, even in the presence of taps and splices. To illustrate this principle, consider a metal raceway extending from a feeder panel to a 12 by 6 inch can, with the conductors passing through the can without any taps or splices. In this scenario, supplemental bonding or grounding of the raceway is typically not required. Conversely, if the same raceway configuration includes taps or splices within the 12 by 6 inch can to feed branch circuits, bonding or grounding becomes mandatory. This can be achieved by connecting a grounding conductor to the raceway and bonding it to the enclosure, thus maintaining a reliable grounding path. The fundamental reason for bonding or grounding metal raceways is to ensure that any fault current that occurs in the circuit will be safely conducted back to the source through the grounding path. This protective measure safeguards both equipment and personnel from the hazards of electrical shock. By providing a low impedance path for fault current, bonding and grounding facilitate the rapid operation of overcurrent protective devices, such as circuit breakers or fuses, thereby interrupting the flow of fault current and minimizing the potential for damage or injury. Now, let's explore the specific methods and techniques employed for bonding and grounding metal raceways. Firstly, one common approach is to utilize bonding bushings. Bonding bushings are specialized fittings designed to provide a secure electrical connection between the metal raceway and the enclosure to which it is connected. These bushings typically feature a set screw or other means of mechanically clamping onto the raceway, ensuring a low resistance connection. Secondly, another method involves the use of grounding lock nuts. Grounding lock nuts are similar to bonding bushings, but they incorporate a threaded hub that allows for the attachment of a grounding conductor. These lock nuts provide a convenient means of bonding the raceway to the enclosure and simultaneously establishing a connection point for the grounding conductor. Thirdly, in some cases, it may be permissible to rely on the metallic continuity of the raceway system itself for grounding purposes. However, this approach is subject to certain conditions and limitations. For instance, the raceway system must be properly installed and maintained to ensure a reliable electrical connection throughout its length. Additionally, the raceway must be adequately sized to carry the anticipated fault current. Fourthly, when installing metal raceways in corrosive environments, it is essential to take precautions to prevent corrosion from compromising the grounding path. This may involve the use of corrosion-resistant materials, such as stainless steel or PVC-coated conduit, as well as the application of protective coatings or sealants to prevent moisture ingress. Now, let's turn our attention to some common misconceptions and misunderstandings regarding the grounding and bonding of metal raceways. One prevalent misconception is that bonding or grounding is only required for raceways that contain high-voltage circuits. In reality, the NEC mandates bonding or grounding for all metal raceways, regardless of the voltage level of the circuits they enclose. The rationale behind this requirement is that even low-voltage circuits can pose a shock hazard under fault conditions, and proper grounding and bonding are essential for mitigating this risk. Another common misunderstanding is that the use of insulated grounding conductors eliminates the need for bonding or grounding the metal raceway. While insulated grounding conductors play a crucial role in providing a dedicated grounding path for equipment and devices, they do not negate the requirement for bonding or grounding the raceway itself. The raceway serves as a supplementary grounding path, providing an additional layer of protection in the event of a fault. Moreover, it is important to note that the NEC contains specific requirements for the sizing of grounding conductors used to bond or ground metal raceways. These requirements are based on the size of the overcurrent protective device protecting the circuit, as well as the length of the raceway. It is essential to consult the NEC to ensure that the grounding conductors are adequately sized to safely carry the anticipated fault current. Furthermore, the NEC also addresses the issue of grounding and bonding in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present, creating a potential explosion hazard. In these locations, special precautions must be taken to ensure that electrical equipment is properly grounded and bonded to prevent the accumulation of static electricity, which could ignite the flammable atmosphere. The NEC contains detailed requirements for grounding and bonding in hazardous locations, including the use of intrinsically safe equipment and explosion-proof enclosures. In addition to the NEC requirements, it is also important to consider any local codes or regulations that may apply to the grounding and bonding of metal raceways. Local codes may impose additional requirements or restrictions depending on the specific circumstances. Therefore, it is essential to consult with a local electrical inspector or authority having jurisdiction to ensure compliance with all applicable codes and regulations. In summary, the grounding and bonding of metal raceways is a critical aspect of electrical safety. By adhering to the NEC requirements and employing proper installation techniques, it is possible to create a safe and reliable electrical system that protects both equipment and personnel from the hazards of electrical shock. The key considerations are firstly, understanding the distinction between straight pull configurations and raceways with taps or splices. Secondly, employing appropriate bonding and grounding methods such as bonding bushings, grounding lock nuts, and corrosion-resistant materials. Thirdly, avoiding common misconceptions and misunderstandings regarding grounding requirements. And fourthly, consulting with local authorities to ensure compliance with all applicable codes and regulations. By following these guidelines, electrical professionals can ensure that metal raceways are properly grounded and bonded, thereby minimizing the risk of electrical hazards and promoting a safe working environment. The specific sections of the NEC that are most relevant to the grounding and bonding of metal raceways include Article 250, which covers grounding and bonding in general, as well as Article 300, which addresses wiring methods. Within Article 250, Section 250.4 outlines the general requirements for grounding electrical systems, while Section 250.92 specifies the requirements for bonding metal enclosures and raceways. Additionally, Section 250.96 provides guidance on the bonding of services, and Section 250.104 addresses the bonding of metal water piping systems and other metal structures. Within Article 300, Section 300.10 requires that metal raceways be mechanically continuous between boxes, cabinets, and other enclosures, while Section 300.12 mandates that metal raceways be securely fastened in place. These sections, along with other relevant provisions of the NEC, provide a comprehensive framework for ensuring the proper grounding and bonding of metal raceways. It is important for electrical professionals to familiarize themselves with these requirements and to apply them diligently in their work. Moreover, it is worth noting that the NEC is revised and updated on a regular basis, typically every 3 years. These updates may include changes to the grounding and bonding requirements for metal raceways, as well as the introduction of new technologies and techniques. Therefore, it is essential for electrical professionals to stay informed about the latest revisions of the NEC and to adapt their practices accordingly. Continuing education courses, industry publications, and online resources can all be valuable tools for staying up to date on the latest developments in electrical safety. In addition to complying with the NEC requirements, it is also important to follow best practices for grounding and bonding metal raceways. These best practices may include using high-quality materials and components, ensuring proper workmanship, and conducting thorough inspections to verify the integrity of the grounding system. For example, when installing bonding bushings or grounding lock nuts, it is important to tighten the set screws or nuts securely to ensure a low resistance connection. Similarly, when splicing grounding conductors, it is important to use approved splicing methods and to ensure that the connections are properly insulated. Furthermore, it is advisable to conduct periodic inspections of the grounding system to identify any potential problems, such as loose connections, corrosion, or damaged components. Addressing these problems promptly can help to prevent electrical hazards and to maintain the integrity of the grounding system over time. In conclusion, the grounding and bonding of metal raceways is a complex and multifaceted topic that requires a thorough understanding of the NEC requirements, as well as a commitment to best practices. By adhering to these guidelines, electrical professionals can help to ensure the safety and reliability of electrical systems, protecting both equipment and personnel from the hazards of electrical shock. Remember that the information presented here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer to ensure compliance with all applicable codes and regulations.